In several videos in my channel, I mentioned I use iPerf 3 to test network speed, and in the comments area of those videos, some folks mentioned whether Jumbo Frame was used. I decided to make this video just to discuss about Jumbo Frame or MTU in UniFi Switch settings and some troubleshooting techniques. The reason is whenever people talk about switch network speed testing, the first comments from many people will be Jumbo Frame MTU. Let's see how important it is and how we make settings. On the screen, I have 3 pages from Wikipedia open. The middle one is about MTU, Maximum Transmission Unit. The concept is very simple. Of course, when you transfer a packet, you need to have a size, the MTU, just to define the maximum size of the unit. In the left side, it talks about Jumbo Frame. Unfortunately, there's no standard enforced for Jumbo Frame or maximum MTU value. Different vendors, they have their different standards, but in most cases people talk about 9,000. Of course, nobody says the bigger the MTU value, the faster speed, but in some situations, for example, when you want to access network storage, the Jumbo Frame or bigger MTU value may help. In the right side, it talks about fragmentation. Think about it. There are multiple devices in your end-to-end network path. If some of the devices are not configured with the same MTU as other devices, then when the system transfer a packet, it will encounter problem when it comes to size. There must be a way to split a bigger packet into smaller units. Fragmentation is to resolve this problem. This is important because many MTU related issues are related to the fragmentation. We will talk about that later in this video. Many times people use term Jumbo Frame to refer to frames which have sizes bigger than 1500. But how big it is? What's the maximum size of Jumbo Frame? To be honest, that's a little bit messy. On the screen, I show you 6 different operating systems. Let's check them one by one to see what's the maximally allowed Jumbo Frame size. The first one is Synology. You can see I input a value bigger than 9,000. If I click on it, you see the error message. It says the maximum value is 9,000. And move on. This one is TrueNAS. Let me try to give it a bigger value. Let's say 10,000. You can see this is the maximum value for TrueNAS because it's based on FreeBSD. So it has different values than Linux or Synology. Move on to this one. This is pfSense. I'm configuring the interface. In the MTU input box, I put a very big value, but see what's the error message. It says it's 9,000. Even though FreeBSD and TrueNAS, they are both based on FreeBSD, apparently they have different MTU settings. So it's not really completely operating system based. Move on to this small dialog. That's the native Mac OS network setting. I'm in the hardware tab. For the Jumbo Frame, only give you 9,000 option, right? But what if I choose custom? Okay, here it tells you the maximum value is 16,000. That's the biggest value I see so far. Move on to this window. This is a Linux machine and it's a Arch Linux. I'm in the network setting. I put a very big value. Let's see what will happen. See, it's automatically changed back to 10,000. Move on to the last window. This is a Sonic network operating system. This is my 100 gigabits switch. If I show the interface status, you can see in the MTU column, most of them have the default 9100 value. But let me use the last one, last interface, which is not used. Let me use it as an example. Let me try to configure a super big MTU value. Let me try to add one. Okay, it doesn't give me any error, but let me show the status again. See, the value is not changed. It still remains the 10,000 value. This is just several examples. You may find other maximum values in your devices as well. But you know what? It's not that bad because the max value is not that important. What's important? The important thing is from end to end in your network path, you need to make sure every device has the same MTU setting. That's the important thing. In UniFi network controller, for each switch, you can adjust the jumbo frame. You can enable or disable it. But this setting is only on the switch level. You cannot assign different MTU values to different ports. It also doesn't mention what's the MTU value it really assigned. It only shows you whether it's enabled or disabled. Let's find it out. Let me SSH into the switch, telnet into itself, run a command to show the details for any interface. Let me pick the very first one. See here, it mentioned IP MTU 1500. That's the default value when I haven't enabled the setting yet. Now let me go to UniFi controller to enable the jumbo frame. I'm going to change this switch, enable jumbo frame, apply changes, give it some time. Now we are back to SSH. Let me run the same command again to see what's the updated MTU value. Now it's changed and it's 9198. It's not really 9000. That's interesting. Good to know. Next, let's use a real world scenario to see the effect of jumbo frame or bigger MTU setting. Here you see my current testing environment. I have a Mac connected to a UniFi aggregation switch, and then it's connected to the Pro aggregation switch using fiber. In another room, I have a Synology NAS connected to the same model aggregation switch, and then connect to the same server room Pro aggregation. Very simple network topology. All the links are 10 gigabits. Now let me use iPerf3 to see what's the performance between this Mac and the Synology. Keep in mind, now for all the devices in the network path, they have the default MTU setting, which means in most cases it's 1500. Let's see what's the performance. From the Mac, let me run iPerf3 against the IP address for the Synology. Everything's default setting, default MTU, default iPerf. As you can see, the average speed is not very good, 6.7 gigabits. The upper limit should be 10, right? Let's see after we change the MTU settings whether the speed can be increased. An important thing to understand is we need to set the same jumbo frame setting in every single device along the network path. In this case, we need to set 1, 2, 3, 4, 5 different devices to enable jumbo frame. They come from 3 different vendors. Let's go through them one by one. First, Mac OS. In the left, you see the standard network setup dialog. For Mac OS, I'm in the hardware tab. By default, it's automatically, and as you can see, the MTU part is disabled, but the gray text suggests it seems the system already automatically selected jumbo, which is 9000 MTU. But I'm not 100% sure from this UI. Let me go to the command line to make sure that's the case. In the right, you see the terminal. I run the command network setup get MTU, and the EN4 is the Ethernet interface name for the current NIC I'm using. Let me run this command. 9000. I'm comfortable. I know, yes, the system does set the 9000 automatically already. We are good in macOS. Let's proceed with UniFi switches. On the screen, I'm using the classical UI because I want to put all the 3 devices side by side on the same screen. The setting is all the same across UniFi switches. So you go to the config and then under services, there's one option for enable jumbo frame. Simply enable it, apply, move on to the next switch. And the same way for the third one. Okay, we are good with the UniFi switches. It's super simple, super convenient. Synology also provides a very good way to change network setting. I'm in the control panel for network. Go to network interface, click your interface, edit, move on to the IPv4. There's a setting here, set MTU value. We choose it and then choose the last value, 9000. Click OK. We are done with the Synology change. Let's go back to the Mac OS terminal. Run iPerf3 client again. Let's see what's the performance now. Okay, much better. Let's see what's the final average. Perfect, 9.6. So basically we achieve 3 gigabits increase in terms of performance. It's dramatically improved. Next, let's talk about troubleshooting. You may encounter some very strange network issues. Some of your network operations may work, some may not. It's very frustrating. Let's look into one example. Let's assume for all the 5 devices, we changed all 4 of them, these 4, but we just forgot, or for whatever reason we didn't change the MTU setting here. So which means for these 4 devices we have the jumbo frame, but for this one we still have the standard 1500 MTU. Let's see what will happen. We are in USW Pro aggregation switch. Let me go to services and let me disable jumbo frame. Okay, now we have the testing environment already. Before I show you the issue, let's try to run the iPerf command again to see what's the current performance. I'm in Mac OS terminal now. Let me run the same command. Okay, I can connect to the system, no problem. But as you can see, the performance degraded to the old bad value. You may say, I'm fine with this speed. Anyway, I can still connect to it, right? Wait a second. Let me show you what's the issue. This slow performance is not the issue I want to talk about. Let me show the issue. This is a Safari browser. Let me paste the URL for Synology Web UI. See, this is the issue. It keeps spinning, thinking, just without connecting successfully. You may say, we just tested iPerf, right? When we test iPerf, yes, the performance is not good, but at least we can connect to Synology, right? And why from Web UI we have issue? That's exactly what I said in the beginning of the video. After you did something wrong in the MTU changes, you may encounter some very weird issues. To understand what really happened, let's launch the Wireshark to see what's the packets sent and received by the Synology. The tool we are going to use is called Wireshark. It's a free cross-platform, very useful network troubleshooting tool. Before we start looking into this particular issue, I want to add 3 new columns. As you can see, I already added them. They are the sequence number, next sequence number, and acknowledgement number. Those 3 numbers are kind of made up sequential numbers from Wireshark. Will be very helpful, easy way to track the sequence of the packets. The way to enable them is you start your monitoring, then find any packet. For example, this TCP IP packet, you will find those columns. For example, sequence number. So just choose any packet you happen to capture and then right click. You will see the apply as column option. You add the sequence number, add the next sequence number, acknowledgement number. You add these 3 columns. I already added them. Now let's start the capturing for this particular issue. I'm going to monitor this interface for my 10 gigabits network, and I set a filter. I say host the Synology NAS IP address here. Start. It start capturing already. Now let me go back to the Safari browser. Let me refresh the page. I still want to visit the Synology Web UI. Click enter. Go back to the Wireshark tool. Okay, it already captured several. In fact, I already see the issue. Let me stop capturing. Now we can spend time on the captured packet. Let's start from packet number 5. In the protocol, you can see it's TLS V1. Why? Because I'm trying to connect to the Synology Web UI, so the protocol is HTTPS. So the system is using TLS as protocol here. Mac OS simply want to establish a handshake. Says, okay, I'm client, hello. Synology should say server, hello. Then the talk can continue. But you see what happened after the 5th packet? You see the different color, the black one. The black one means something goes wrong and the packet was resent. Let's look into the 9th packet. See, it's from Synology to macOS. It says, I sent you something you didn't acknowledge. But from the packet we just captured, we don't see anything sent from Synology. And if you check the sequence number here, it's showing 1881. Something went wrong here because the sequence should start from 1, but now it says 1881. That means we lost something. What's the information lost? The length is exactly 1880. You can see from the content of this packet, Synology asked macOS, you didn't respond. What happened? That's exactly where the issue is. We lost a packet from Synology to macOS. Safari web browser cannot establish a handshake with the Synology. Even though I do have the connection to Synology, the handshake cannot be established. Why? If you check the lost packet length again, it's 1880. What's the issue? It's bigger than 1500. Now we can already guess that might be the cause. MTU is the troublemaker. In the beginning, we mentioned that there's something called IP fragmentation. If the Synology and my switch, they have different MTU, it doesn't matter because my switch will ask Synology to resend the huge packet in smaller units so that the handshake can still be established. But why this time this mechanism didn't work? Let me make the setting correct. For now, let's monitor a correct handshake to understand what really happened. To do that, let me go back to the network controller. I'm already in the setting for USW Pro aggregation. Remember, that's the only UniFi switch which we disabled the jumbo frame. Let me enable jumbo frame here, apply changes. Now let me go to Wireshark again. Let me start capturing from the web browser. Let me try to refresh one more time to see this time whether the connection can be established. See, I already see the expected error because of the certificate issue. That's the message you may be familiar already. But anyway, after seeing this message, that means the connection is okay already. Let's go back to Wireshark. We already see a long list of packets captured. Let me stop the capturing and scroll to the beginning. I find this packet. Similarly, Mac OS sent to Synology. I say client hello. See here, this is the difference. We didn't see this packet 5 minutes ago. In this packet, the Synology answered. The source is Synology, target is Mac OS, is TLS, and the sequence number is 1, and the next sequence number is 1881. See this familiar troublemaking number, right? The content is server hello. This is the exact packet we lost 5 minutes ago. That's why before re-enabling the jumbo frame, the connection couldn't be established. Let's see why this packet is so special. This is flag I'm looking for. See, in this packet, it's set don't fragment. That's an important flag. Synology doesn't want this packet to be fragmented. Synology set the packet, set this flag. The packet length is 1880. It's longer than the MTU. The UniFi switch, when it received the packet from Synology, the UniFi switch will try to fragment it, try to send it in 2 smaller units, but Synology doesn't allow that. You may ask, the packet is so long, why if I set every device, I set the MTU as 1500, which is smaller than this number, I will be able to establish the connection. Let's see why is that. To validate that situation, we only need to set the MTU for Synology, set it back to 1500. Then we can reproduce the scenario. I already restored the MTU setting for Synology from 9000 to 1500. Even though I didn't change the MTU for the 3 UniFi switches and the macOS, it doesn't matter because as long as the Synology, that one single device MTU setting is changed, the effective one should be 1500 from Synology. Let me re-enable the capturing from Wireshark. Then go to the web browser, refresh. Go back to Wireshark. Let me stop capturing and then scroll to the beginning. Start from this packet. macOS says to Synology client hello, and then let's see this one. This was the TLS protocol. It says what? Server hello. But if you look at the next sequence number, this time it's not 1881, it's 1449. Why is that? And then you look at the next packet. This one starts from 1449 and the end number is 1881. Again, the familiar number, right? The long 1880 packet was splitted into 2 units because we changed the MTU setting in Synology. So the Synology knows, okay, my max unit length is 1500, but now I want to send a longer one, so I have to split this big packet into 2. The splitting happens in Synology, not in UniFi Switch. To confirm that's the case, let's click on this one and try to find the don't fragment flag. See here, it's set as don't fragment as well, but it doesn't matter because the length is 1440. It's not exceeding the 1500 upper limit, so UniFi Switch will still make the transfer happen, so nothing is wrong. And if you check the second packet, again similarly the flags don't fragment. Even though both packets they set as don't fragment, but the handshake can still be established because the splitting happens in Synology based on the MTU setting. Okay, I hope after the back and forth revalidations, now you can understand why just by forgetting a change in one of the device, it will cause the Synology Web UI access issue. Hope this is helpful. Thanks for watching.